there's one final thing I want to show off about tail recursion. So remember that we said that the reason why we like tail recursion, or at least the theoretical reason why we like tail recursion, is the fact that it kind of gets rid of the call stack, right? So we can just reuse the previous stack frame, or use what I call multiple stack frames in the book, where we just replace the parameters of the existing stack frame call and just use that. Okay? So in theory, this should not stack overflow. So let's see what happens when we call, let's say we call, I don't know, this with a very large number like that. And then we just pass 3, so this should return, what should return? 1,000,002. The method stack overflows. So what's going on here? This implies that we're still using the call stack, right? And indeed, we are still using the call stack. So what I've tried to demonstrate in this series of tail recursive videos is something called tail call optimization. Tail call optimization is when a programming language tries to rewrite tail recursive calls in a way that doesn't use the procedure call stack. Okay? So many functional programming languages do use this implementation, because in a lot of functional programming languages, recursion is the only way to do things. It's the only way to write algorithms that decompose their input or traverse over things like strings, or as we'll see in a future video, things like collections, like arrays, or as you might know them, lists. Now, Java does not do this optimization, and that really kind of stinks, because all this work that we've done, and we haven't really gotten anywhere. Like, we've written all of these nice tail recursive methods, we've talked about tail recursion, we've talked about the benefits of tail recursion, but we don't see any of those benefits, right? We're still using the call stack. And you may think, well, what are we going to do now? Well, we have these tail recursive algorithms, and we're kind of at a dead end. Well, here's the thing. We're not at a dead end. The thing is, we can always convert a tail recursive method into something that does not use the procedure call stack. Okay? Something that does not use the procedure call stack. Or at least it doesn't use it in the way that we think that it will in a recursive algorithm. That thing is called a loop. We can always mechanically convert a tail recursive algorithm into an equivalent loop. Now, what are loops, or what is a loop? That's something we'll learn about next time.